Okay, let's unpack this. You've shared some material about the DP-600 exam for Microsoft Fabric.
Mm-hmm.
And it looks like, well, you're maybe aiming to get a handle on what this certification covers,
Mm-hmm.
or perhaps prepping for the exam.
Or just curious, right, about data management, analytics, all within that Microsoft ecosystem.
Exactly. We've got this breakdown of the exam basics,
Mm-hmm.
web-based, covers key Fabric features, and also a set of practice questions. These really dig into the specifics.
Yeah, they do.
So our mission here, it's not really just about the test itself, is it? It's more about extracting the genuinely useful knowledge, the insights about actually working with data in Microsoft Fabric.
Precisely. Think of it like using the exam questions as a sort of map to understand the why behind the what. Why are these features important?
Right. Why do they matter in practice?
Yeah. What's fascinating, I think, is how these questions act like a focused lens. They really highlight the core capabilities, the fundamental principles you need if you're working with data in this environment.
So it's kind of a structured way to learn, even if
Yeah.
you're not actually taking the exam.
Exactly. A pathway to understanding Fabric's core.
Okay, good. So let's dive right in then. First question that came up was about row-level security, RLS.
Ah, RLS.
The answer points to configuring roles and applying filters to tables using DAX. Now, okay, that's the exam answer, but let's talk about the real world. Why is this important? Grasping how to manage data access like this.
Well, it's absolutely vital. I mean, think about it from a security perspective. This isn't just a Fabric thing. It's a core data governance principle.
Okay.
RLS lets you control exactly which rows of data-specific users or groups can see within the same table. You mentioned sales data before, perfect example.
Like the regional manager example.
Exactly. The North region manager only sees North data, South sees South. You define these roles, and then you use DAX, which is that formula language, from Power BI and analysis services.
Familiar ground for many.
Right. You use DAX to write the filter rules for each role directly on the tables. So the rule might be something like region North.
So it operates right down at the individual row level.
Precisely. At the row level within specific tables. And roles are how you define it. It's crucial for, sensitive data and multi-tenant situations, compliance, making sure people only see their slice of the pie.
That makes sense. It prevents that accidental oversharing of data.
Or intentional sometimes. It's a key control. So for you listening, think about where you have data that not everyone should see all of. RLS is likely the mechanism you'd use in Fabric.
Okay, clear. Let's move to the second question. This one introduced direct lake mode.
Ah, direct lake. Yeah, this is a big one in Fabric.
The explanation says it lets semantic models directly query Parquet files sitting in one lake. It sort of bypasses the usual query engine for faster performance.
That's the key idea, yes.
And it blends the speed of import mode with the data freshness you get from direct query. That sounds, well, almost too good to be true. How does cutting out that middleman make such a difference?
It's about architecture. Think about import mode. You copy data into the Power BI engine. It's fast to query, but the data can be stale.
Right, you have to schedule refreshes.
Exactly. Then there's direct query. It queries the source live. So fresh data, but potentially slower queries because you're hitting the source database each time.
Okay.
Direct Lake aims for the best of both. The data stays in one lake. Typically, as Parquet files, these are already optimized for analytics.
Columnar format.
Exactly, columnar. And Direct Lake lets the Power BI engine, or rather the Fabric semantic model engine, read those Parquet files directly from the lake storage. It understands the format.
Ah, so no need to import it fully and no need for a slow translation layer like traditional direct query might have sometimes.
Precisely. It skips loading data into memory like import mode and avoids some query translation overhead you might see elsewhere. It's accessing the data where it lives in an optimized format. The result, much faster performance than direct query, often approaching import speed, but without copying the data.
Wow. So the aha moment is really that performance gain on potentially huge data sets while still querying relatively fresh data sitting in the lake.
Yes, especially for large data sets in Fabric where import isn't feasible and direct query might be too slow. Direct Lake is a game changer. If you need fast analytics on big data in Fabric, you need to understand Direct Lake.
Makes sense. Okay, question 3. This one was about building real-time dashboards using data from something called a Fabric Event House.
Even House, yeah. Part of the real-time analytics workload in Fabric.
And the feature mentioned is Fabric Real-Time Analytics. So this points to Fabric being able to handle like streaming data, for immediate visualization.
Spot on. Think of data that's constantly flowing, sensor data from IoT devices, website clickstreams, application logs, financial tickers.
It's happening right now.
Exactly. An event house is designed to ingest and store these high-volume, high-velocity event streams, and Fabric Real-Time Analytics provides the tool, specifically KQL query sets and connections to Power BI.
KQL, Custom Query Language.
Yes, Custo query language. You use KQL to query that streaming data in the event house, and then you can hook that directly into Power BI dashboards.
So the dashboards update almost instantly as new data arrives.
That's the goal, near real-time visualization. It's not just about seeing historical data. It's about seeing what's happening now. Think about monitoring system health, tracking live sales figures during a promotion, or detecting anomalies as they occur.
So the benefit is that immediate insight, leading to potentially immediate action.
Absolutely. It enables that quick response cycle. If you're seeing website errors spike right now, you can react immediately, not find out hours later from a batch report. For you, consider where seeing data as it happens could provide a real advantage.
That's powerful stuff. Okay, let's switch gears slightly to data governance. Question 4 brought up sensitivity labels,
Important topic.
specifically for automatically labeling and classifying sensitive customer data stored in a lakehouse. So this isn't just about finding data, it's about understanding how sensitive it is.
Exactly. It's about classification and protection. These are the same sensitivity labels you might know from Microsoft Purview, integrated into Fabric.
Okay, so consistency across the Microsoft stack.
Right. You can define labels like public, internal, confidential, highly confidential, maybe with subcategories like PII or financial.
Got it.
And the key thing here is they can be applied manually or automatically based on pattern matching, like detecting credit card numbers or national ID formats within your lakehouse data.
Ah, the automation piece. That sounds really useful.
It is. Once a label is applied to, say, a table or even specific columns in your lakehouse, it acts as metadata that travels with the data. Then, downstream policies can use these labels. For example, a Power BI report built on data labeled highly confidential might automatically inherit that label and have restrictions applied, like preventing export.
So the label informs the protection policies automatically.
Yes. It helps enforce data handling rules, contributes to compliance like GDPR or HIPAA, and just generally improves your data governance posture by making sensitivity visible and actionable. It's proactive protection.
Very interesting. Okay, next up, question 5 dealt with deploying changes between Fabric workspaces.
Deployment pipelines, essential for any serious development.
Right. The scenario was moving changes, say, from dev to test to production, while keeping a version history. And deployment pipelines was the answer. I definitely see why doing this manually would be messy.
Oh, incredibly messy and error-prone. Exporting, importing items, hoping you got everything, no easy rollback.
Yeah, not ideal.
So how do deployment pipelines make this better?
They provide a structured visual way to manage the lifecycle. You typically set up pipelines with stages like development, test, and production, each linked to a Fabric workspace.
Okay, like a standard CI/CD flow.
Exactly like
Sure.
that. You develop in the dev workspace. When ready, you use the pipeline to compare dev with test. It shows you the differences, new items, changed item.
Oh, that comparison is useful. Very. You select what you want to deploy, and the pipeline moves it to the test workspace. Then testers do their thing. If all's good, you repeat the process. Compare test with production, deploy.
And it handles dependencies. Like if a report depends on a specific semantic model.
Yes, it manages those dependencies during deployment. Plus, it has built-in versioning and allows for rollback if a deployment introduces problems. It brings control, repeatability, and safety to the process.
Definitely sounds essential for team environments or critical production systems. Avoids those, oops, I overwrote the wrong thing moments.
Precisely. If you're managing Fabric solutions beyond just personal experimentation, you absolutely need to understand and use deployment pipelines.
Good advice. Okay, final question we looked at, number 6. This focused on optimizing Spark job performance.
Getting into the engine room now? Apache Spark?
Yeah. The specific suggestion was increasing the number of partitions in the dataset to boost performance. Why does splitting the data up help Spark run faster?
It's all about parallelism. Spark is a distributed processing engine, right? It works by breaking down large tasks and running pieces of them across multiple worker nodes, multiple cores.
Right.
A partition is basically a logical chunk of your data. When Spark processes the dataset, it typically assigns one task per partition.
Ah, so more partitions means more tasks.
Exactly. And if you have enough compute resources, enough cores available across your Spark cluster, then more tasks can run in parallel at the same time.
Like having more checkout lanes open at the supermarket.
Perfect analogy. If you have one giant partition, only one task can work on it at a time, even if you have hundreds of cores sitting idle. But if you break that data into, say, 200 partitions, Spark can potentially run 200 tasks concurrently, dramatically speeding up the overall job.
So strategically partitioning your data allows you to better utilize the parallel processing power of Spark.
That's the core idea. Now there's nuance. Too many tiny partitions can add overhead. But generally, ensuring your data has a reasonable number of partitions, often related to the number of cores available, is a key optimization technique for large-scale data processing in Fabric notebooks or Spark job definitions.
Got it. It's about finding that sweet spot to maximize parallelism.
Right. It allows Spark to divide and conquer effectively.
Okay, wow. This deep dive, it was really just a starting point, wasn't it? There's obviously much more to explore within each of these features.
For sure. And maybe the most compelling thing, for me at least, is seeing how these pieces fit together. They're not just isolated features.
Right, they form a platform.
Exactly. RLS secures the data that direct lake queries, which might feed a real-time dashboard, while sensitivity labels track its governance and deployment pipelines manage its rollout, all potentially using optimized Spark processing underneath. Understanding that synergy, how they complement each other, that's key to building really powerful solutions in Fabric.
That's a great way to put it, the interconnectedness.
Yeah.
So based on all this, what other parts of data management or analytics in Fabric are you maybe curious about now? What questions has this sparked for further exploration?